Okay, welcome everyone. We are here today in Lough Ree Access for All, which is also the National Accessibility Water Sports Centre here in Ireland. I'm Sheena Fennell. I'm a Senior Technician in Earth and Ocean Science at the University of Galway.
I'm Aedín, McAleer, and I am a Senior Technician in Zoology and a Research Assistant in Earth and Ocean Science. And we are here today to go out on the boat on the River Shannon, and we're looking at scientific instrumentation here today.
Okay, so welcome on board the Lough Ree Access for All boat. As you can see, it's very, very accessible, and we hope you enjoy our spin today.
While we're out on the boat today, we're going to go through some of the instrumentation we use for environmental monitoring, which relates to our work in the University of Galway. So the first instrument we're going to walk through is a castaway. A castaway is a robust temperature, salinity and depth sensor. So reasons why we take temperature is to look at the temperature of the water profile. So by profile I mean when this goes into the water, it will measure from the surface down to the bottom and back up continuously, so it'll give you a temperature for every depth the whole way. Same with salinity. So in summer you have things like thermoclines where the surface of the water heats up with the sun, and you'll be able to physically see that when you put this in the water. You'll be able to see the increase in temperature and then the decrease as it goes down in depth. And then the same back up, it's colder at the bottom and then warmer at the top. It also measures salinity, which I've mentioned, but salinity is 0 usually in freshwater. But if we were in the sea, you can have salinities up to 35, 36, and this will be able to show you different salinities through the water column. Okay. So how this works is we turn it on through here, and we want to set up a measurement to take a profile. So it just takes a wee second to find GPS, because it also logs our GPS, so we can look at this afterwards and see exactly the spot that we were measuring the temperature and salinity. So that's that connected now. You can see the little screen has gone green. So if we enter into this, okay, it's green, so it's happy that it has the GPS and it gives us its latitude and longitude there. And then what we want to do is, when I press go, we want to lower this just into the water so it just can kind of begin to settle, and then in a few seconds then we can release it and let it slowly drop down. And then once it reaches the bottom, you'll kind of see the line go slack, and then we can reel it back up, and then that will be it basically. Okay, so that's ready to go if you're happy to just drop it into the water. Okay, so we'll just leave it there for a second.
Okay.
Yeah. And then if you want to slowly lower it down. Yeah. No, it doesn't have to be too slowly, just.
Okay.
Yeah, and then we can begin to pull it back up.
Okay.
Yep, that's all good.
And pull it up slowly.
Yeah, just kind of. Yeah, that's good speed there. And there we have it.
Will I keep going?
Yeah, keep going. Right up.
Okay.
Yeah, perfect. And then I'll give you a hand to lift her up. So that's it. That's perfect. If you want to just kind of let a little bit of slack.
Let it off a bit.
Yeah, just so I can bring it back down to you. Yeah, perfect.
Okay.
Yep. So then we click that we're ready to finish. It's happy at our end location. And now it tells us the date, the time where we took the sample, the depth, which was 5.72 metres. It took us 1 minute 40 seconds, and in that time it took 490 samples.
Oh God.
And then you can see here on the screen, you can see the temperature was fairly constant through the bottom. Same with salinity, 0. And then, yeah, that's it. And we can show that in larger screen as well on the computer.
That's deadly.
So that's basically this one.
Yeah.
So that's the Castaway. So then another instrument that we can use for temperature and salinity is a YSI. So I will just
Yeah, no
drop
problem.
this down. So this is a YSI, which basically does the same thing. It measures temperature and salinity. So we'll just turn this on here.
Pity you didn't have a wiper on.
I know. A wiper would be good. So you can see out of the water, you can see the temperature there.
Okay.
So it's not measuring salinity because it's not in the water.
Yeah.
But if you would like to hold that, and you'll be able to read out. So I will lower this
Yeah.
into the water, and you'll be able to see the change.
Okay. Very interesting.
So I'm just lowering this down about a metre into the water, and then you can see the temperature drop.
Yeah. Okay.
So we'll let it settle because it takes a few seconds to settle. But this gives you, the YSI or the Castaway goes down and up, but you can't really see the data till after.
Yeah.
This gives you like straight away data, so you can see.
Oh yeah.
So we've 8.8 degrees
8.8 degrees
and 0.05 salinity, which is about right for freshwater.
Yeah.
And it's as simple as that, yeah. So that's and it showed a very similar situation on the Castaway.
What is salinity? Like, is that?
Salinity is the amount of like dissolved salts in the water.
Yeah, that would be more in the sea.
Yeah, so seawater has a salinity up to 35, 36.
Okay.
In coastal areas with mixing of fresh water and seawater, you kind of, like in Galway Bay, for example, you have salinities around 28 to 33 in some places, depending on the tide and the time of year and so on. So,
Oh no, that's
yeah.
deadly. Yeah.
So,
Very good.
yeah. Happy enough? Yeah. Did I cover everything? Are you happy? Did that make sense?
Oh,
Are
yeah,
you very happy? Yeah.
That's why I asked the question. as well,
Yeah, yeah.
because I was
Oh no, it's great. Yeah.
Yeah, I was just curious, like, so yeah, it's deadly.
Okay, Mark, so Aedín went through kind of the temperature and salinity and how we measure it, and then obviously we want to take water samples, okay? So we take water samples for all different things. So, we might take it for how much oxygen is in the water, how much nutrients are in the water, which are important. I suppose any nutrients in the water are quite important. And then, we take all different, we might take it for chlorophyll. So chlorophyll, a lot of the plants that live in the water have chlorophyll in them, okay? And that would be kind of our planktons. So we take water samples, and how we do it is with this style of equipment called a water bottle, okay? Now I actually have it opened, but normally it's closed, okay? And what it is that obviously you drop it into the water to whatever depth you want. Normally, like what Aedín was talking about, is that you might have that thermocline, so where it's really, really warm at the surface and it's quite a little bit colder at the bottom. And so you might say, okay, we'll sample in the surface to see what are the nutrients there, and we'll also sample at the bottom to see are there differences. Because they're kind of, they're that kind of temperature, or that thermocline where there's a sharp change in temperature, can act as a barrier for movement of loads of different things. So the way that we do it is we usually have it weighted, okay? And on the larger vessels they would have, a circle of these. So you might have, 12, 18 bottles that go around, and you know, you might be dropping to 3,000 metres of water, and then it means you can sample all the way up, okay? You can fire them electronically on the larger boats, but today we're going to actually what we call fire it mechanically. So I'm just going to pop it over the side. Okay, so it's open, so as we're going down through the water column, it's open, so you know, it's going to sample where we actually close it. And how we're going to close it is with this, okay, and this is what we call a messenger. And all that does is it goes down the rope, and there's like a white button on the top of the water bottle, which I'll show you when it comes up, and it just pushes that down, and then it closes the top and the bottom of the water bottle. So then we have water from that particular depth. Yeah, makes sense, yeah? So I'll give that to you. Okay, what we'll do today is we'll just go down to 2 meters, okay? So we just have it marked off on the rope. And then for you, I'll show you, actually, I'll probably show you, is you just open it. They can be a bit tricky. And then this goes in like this, yeah? And then you let it, and then you'll just let it go, yeah? So now it's attached to the rope, it doesn't come off, okay? And then all we do is up and then just over. Yeah, and we're just gravity, and if you might be able to feel it. Sometimes you can feel it go clunk, clunk, like that, okay? So now I'll bring it in. And it didn't fire. Why didn't it fire? This is the beauties of working. The reason why it didn't fire probably is because there's quite a strong flow on the river today. So it goes down a little bit. So for today what we'll do is I'll just drop it to 1 metre. Okay? So we would often experience that when we're out, especially if there's a tidal current. As it goes down, it gets pulled by the tidal current. The kind of solution is you can always put on more weight, you know. But we'll try and go to 1 metre here today. Okay, and then off we go. I don't think it's going to play ball. We'll just go the surface then. No. Okay. No. I actually what I might do, right, is we have a second one of these, a second one of these guys, so I'm just going to put it on. But these are the kind of difficulties, I suppose, that we have often when we're out sampling. Do you know that, like, you get into a place where you haven't sampled before, and you know, you just have to adjust when it's all fine and well when you're sitting.
On top of that one now.
We'll go for a double one, yeah.
Oh yeah, for the bit more weight.
Exactly, yeah. Because what's happening is just that
Pull on the rope,
exactly, so it's getting pulled back. So what I'll do is I'll give those to you, and you can hold on to them for me. And Harry, I might actually get you to kick astern a bit in a minute, if you don't mind. Okay, and we'll try again, Mark, so I'll take them off,
No problem.
It's just the joys of... Okay, we'll try again. Yay, and we got it. Okay? Yeah, so now we actually have the water here, okay?
Oh yeah, that goes to the bottom as well. Okay,
yeah. So there, what we would normally do is, like, so this closed, it came down onto here and just forced it closed, okay? And then we'll sample through here. So we normally then will sample into different bottles, you know, for different parameters for whatever we want to record, Yeah, and then, so if we did that at the surface now, then we could go back and then, you know, sample maybe 2, 3, 4 meters down, whatever we're in, to see, are there different, you know, are there different characteristics? Is there more oxygen at the surface?
Like irregularities on
Exactly, yeah. And then that would go out then as well for when we go actually offshore of Ireland. So, you know, once we go off, we're into 3,000 meters of water, and there's different water masses out offshore, and we sample those to see, okay, what are the nutrients, what are the oxygen, you know, what's the temperature. It just gives us an idea of what water masses are there. And when we talk about water masses, it's, you know, off the coast of Ireland you have Mediterranean water, which a lot of people go, what? Yeah, so that would sit maybe 600 to 800 meters depth. You have water that comes from the Labrador Sea as well that comes down. So, you know, we get different characteristics of different water masses, and that's how we find out where they are.
It'll be different in all many different rivers and lakes.
Oh, absolutely, yeah, and different in the coastal environment and different offshore, But it's the way that we figure out what is there.
Exactly.
Yeah.
That's
Yeah, cool. Okay, Mark, so now we're going to put in a little ROV, a remotely operated vehicle, okay? And we would use these for different things. Obviously, this is quite a nice compact one. You know, they go up to absolutely huge, okay? So the Holland ROV would be the one that's run by the Marine Institute here in Ireland. And that would be used out into about 3,000 metres of water, okay? And they would be looking kind of, you know, it's really to get down onto, you know, either a canyon system or onto the seabed to see what is actually happening. Okay, because you get actual video for it, okay? You can use them for all different types of surveys. Like for an ROV, you can actually take samples and bring them up, so they would be used across a wide variety to actually try and, you know, recognize new species, or often, you know, to actually take a species back and find out what is the chemical composition of that species, because often it can have uses in drugs and, you know, in really positive, you know, that then they can chemically synthesize it. So what we're going to do is you have a setup here, okay, and it's just like a Game Boy, and we have two controls, left and right, okay, and then up and down, okay.
Right. Okay.
Yeah. So we're going to pop it into the water, and so you can actually see the video of what's on the seabed, and it's a really good way to see and look, okay, how healthy is the seabed, or the riverbed, I should say, you know. But we use it across rivers, lakes, you know, coastal, offshore, okay. So we will deploy it now, okay, and I'll just pop it in. And in she goes. And you can start driving there, Mark, and you should be able to see underwater. I'll come alongside you. Yep, she's starting to go down. Yeah, that's it. Thanks, Adrian. Let's have a look. It's probably quite murky because
it's very dirty water.
it is, and the reason would be is because today so you can see the depth going down here, okay, and the reason why is because, you know, we're after a time that there's been a huge amount of rain, so we're in a river, so there's a lot of runoff, okay, so that runoff comes in. Now you're motoring. So that runoff comes down into the water from, you know, the surrounding land, and you can get quite a lot of what we call CDOM, so colour dissolved organic matter, in the river. So you might not see a huge amount today. But you can imagine if it was after a very settled, you know, period or whatever, you'd actually get to see quite a lot, you know.
I'll try and see if we can find a fish.
We'll bring them home. Yeah. Okay. Yeah, that's perfect. Yeah. Okay, thanks for joining us. That was just a quick synopsis of some of the styles of instrumentation that we use both to look at our marine and freshwater environments and how they change. I want to say a huge thank you to the College of Science and Engineering, the Equality, Diversity Inclusion team for supporting this initiative. And over to Aedín.
So if you would like to find out more about this, you can visit the University of Galway website, their LinkedIn and Twitter, and to find out more about Lough Ree Access for All, you can follow them on Twitter and Facebook to find out about the amazing work that they do here and to find out more information about the boat. Thank you very much.